Hello students, we're going to construct the orthocenter of a triangle. For this one we need a kind of small triangle because the paper clip has to reach from the vertices to the opposite side. I'm going to do a small acute triangle. The orthocenter is a point of concurrency of altitudes. So we need to find the altitude of each side. And altitude goes from the vertex through the circle to the opposite side, and it makes a right angle with the opposite side. So we need to drop a perpendicular. The easiest way to do this is to not use a paper clip, but use something that has a right angle on it and just line up the right angle right here at the bottom and then straight draw it down. But this channel is about using paper clips for construction, so I will do the construction. I'm going to create an altitude from that point to the opposite side. The way I'm going to do that is mark along the opposite side 2 points. So intersect the opposite side at 2 points. For this one, these two places are equidistant from the vertex. For this one, I need to extend the opposite side. So I'm going to just make this side a little bit longer. So I have 2 points on the opposite side that are equidistant from that point. And altitude is perpendicular. So I'm going to find the perpendicular. This goes back to the perpendicular bisector construction. I come out to this point. Okay. If I connect here to the vertex, I am creating a perpendicular. It is not the perpendicular bisector, but it is perpendicular. It is perpendicular to this side of the triangle, and it goes through this vertex. This, what I just drew, is called an altitude. I'm going to do the same thing for the other two sides of the triangle. I'm going to go from this vertex, and I need to drop a perpendicular to the opposite side. I'm going to use the far one again. I'm going to mark off 2 places on the opposite side that are equidistant from that point. And this one I need to extend the opposite side again. I have a point here and a point here, equidistant from this vertex. I'm going to use that to find where a perpendicular would be. Right here they intersect, so I'm going to connect that point to the vertex, and this is my second perpendicular, my second altitude. So I created an altitude from the vertex to the opposite side, and it's making a right angle. I'm going to do that with the last side. Sometimes it helps to turn the paper. I'm going to keep it the same orientation, but if you're having trouble, you can just turn your paper and it might be easier. Okay, I'm going to go from the last vertex, and I need to find perpendicular to the opposite side. I'm going to go find 2 points on the opposite side that are equidistant. There's one there and one there. So these 2 points right here are equidistant from that point. I'm going to use those 2 points to find the perpendicular. All right, I'm going to connect the vertex to this point out here. I have now created all 3 altitudes, and you can see that they have a point of concurrency. They all match at the same point. That's your point of concurrency. The point of concurrency of altitudes is called the orthocenter. Orthocenter.